Hello friends, today we are going to solve one more problem from JEST 2020 and basically part C question number 4, and this is basically from laser. So in that question is given, you have a laser. You have a laser and the power of this laser is given. The power of this laser is on 50 milliwatt. Okay, and also it is provided the beam diameter. Suppose it's a beam. That is the beam of output laser. The beam diameter is given. The diameter of this beam is 2 millimeter. Okay, so you have to calculate the amplitude of electric field associated with this beam. So basically you have to calculate that E0, the amplitude of electric field you have to calculate. Okay, so very fundamental question that relate also the concept of propagation of electromagnetic wave in free space. So as you know, to calculate this amplitude of electric field, we have to apply the concept of intensity I of electromagnetic wave, and that is nothing but power divided by area. Now see here, the area that that propagation of EM wave is not like a spherical. However, this kind of disk. Okay, so you have to consider, for ordinary source of light, that propagation of light is kind of spherical. But here, the propagation of light from laser is no longer be like a spherical shape, but it's kind of, you can think like a sphere, like a disk. So here you have to consider that area of circle, or can think that area of disk. Okay, that is the main difference here. Okay, so what I'll do, that intensity that I know power divided by area, that I can keep like a P divided by pi into R square. Okay, and also from that concept of propagation of EM wave, I know that intensity of EM wave is nothing but, in free space especially, it is 1 by 2 epsilon naught C E naught square, where E naught is the amplitude of electric field that you have to calculate in volt per meter unit. Okay, so diameter is 2 millimeters. So obviously radius of this beam will be how much? That will be 1 millimeter. Okay, so now if you rearrange, basically you will get from this equation, if you correlate it, you will get that amplitude of electric field that will be twice P divided by pi, then epsilon naught, then C, and you have R naught square. Okay, now to make life simple, what I'll do, I'll multiply by 4 and I'll divide by 4, because I know the value of 1 by 4 pi epsilon naught. Excuse me. So just I'll substitute this value. So first of all, you have a 1 by 4 pi epsilon naught, that is nothing but 9 into 10 the power 9. Then you have a 8 multiplication factor, and P is given 150 milliwatt. So in SI unit, it will be 150 into 10 the power minus 3 watt. Right? So then you have a C, that is 3 into 10 the power 8, and R naught, sorry, R is on millimeter, so it will be in meter, it will be 10 the power minus 3 square. Okay, so if you calculate this, you have a 1 by 4 pi epsilon naught, 9 into 10 the power 9, 2 into 4, 8, power 150 milliwatt, so it will be 10 to the power minus 3 multiplication factor. Then you have C, that is 3 into 10 to the power 8, and R in millimeter, so in meter it will be 10 to the power minus 3 square, R square, right? So if you calculate it, you will get that amplitude of electric field in SI unit, it will be 6000 volt per meter. So this will be the answer. Okay, thank you.